Hello, calculus student. So, you want to learn about motion? Well, that's great, because that's what we're going to be talking about today. So in calculus, there's three main components to motion: position, velocity, and acceleration. We're not going to talk about speed because it's just the absolute value of velocity. So let's start with position. Position is defined by an object's location at a given time, and it's typically given by a function with a variable for time, such as t. If you're ever asked about initial position, that's just when the time equals 0. That's the original position that the particle started out in. Let's work through some problems so that we can practice what we know about position. So let's say we're given the problem, find the position at x equals 3 if p equals 3x squared plus 2x plus 3. Now this is simple. All we have to do is plug in 3 for x, because x is the variable for time, and 3 is the time that we want to know the position at. So that would become 3 times 3 squared plus 2 times 3 plus 3, which becomes 3 times 9 plus 6 plus 3, which becomes 27 plus 6 plus 3, which equals 36. Simple, right?
Now we are going to be talking about velocity, which is defined as a change in position as time changes. In more simple terms, the velocity of an object is the derivative of the given position. Instantaneous velocity is the velocity at a given time. Now that we know the basic concepts of velocity, let's get started on our practice problems. Find the instantaneous velocity of f of t equals t cubed plus 4t squared minus 17t plus 1, given time t equals 3. Now, in this one, you already have position. You're trying to find your velocity. So what we are going to do is take the derivative of the original equation. F of t turns into f prime of t equals 3t squared plus 8t minus 17. After that, you plug in t equals 3 into your derivative. That becomes f prime of 3 equals 3 times 3 squared plus 8 times 3 minus 17. Then you solve. F prime of 3 equals 3 times 9 plus 24 minus 17. F prime of 3 equals 27 plus 24 minus 17. So f prime of 3 is equal to 34. And that is your answer. Your next problem is if the position of a particle is given by x of t equals 100 minus 16t squared. Find the position of the particle when velocity is 0. In this problem, you're trying to find position. So, first, what you are going to need to do is take the derivative. X prime of t equals 0 minus 32t. Then, what you do is you make x prime of t equal to 0, and you solve. Negative 32 divided by negative 32 is 1. 0 divided by negative 32 is equal to 0, so t is equal to 0. You then plug in t equals 0 into your original equation. What you get is x of 0 equals 100 minus 16 times 0 squared. So x of 0 is equal to 100.
Now that we know about velocity, let's talk about acceleration. Acceleration is given as the second derivative of position, or the derivative of velocity. Acceleration is a change in velocity over time. When acceleration is positive, the velocity is increasing, and when acceleration is negative, the velocity is decreasing. Let's do some problems to find out more about acceleration. Let's say we're asked to find the instantaneous acceleration at x equals 2 if f prime of x equals 6x squared minus 4x plus 2. Now since we already know the first derivative because we're given f prime of x, we know the velocity. And to find the acceleration, all we have to do is differentiate once more. F double prime of 2 becomes 12x minus 4, and then we plug in our variable of x. So we get 12 times 2 minus 4, which equals 24 minus 4, which equals 20. Just as a side note, it's important to remember that since the acceleration is positive, the velocity would be increasing. Now let's say we're asked to find the instantaneous acceleration at t equals 4 if f of t equals 3t squared plus 5t plus 2. So since we're given the position, we have to find the derivative. And the derivative of f of t comes out to be 6t plus 5. Now we have velocity, but we're looking for instantaneous acceleration. So we find the derivative once more, and we get 6. Now this would be the acceleration because there is no variable for us to plug in. So the acceleration in this problem is constantly 6.
Alright, here's the FRQ. The graph below represents the velocity v in feet per second of a particle moving along the x-axis over the time interval from t equals 0 to t equals 9 seconds. A. At t equals 4 seconds, is the particle moving to the right or the left? Explain your answer. What you have to notice is this is a velocity graph. And for a velocity graph, if you're above 0, you are positive and you are moving to the right. If it is below 0, it is negative and you are moving to the left. So we check t equals 4, and at t equals 4, it is above the graph. That means it's moving to the right. So how you state this: the velocity of the particle at t equals 4 seconds is moving to the right because the velocity is positive, or v of t is greater than 0. B. Over what time interval is the particle moving to the left? Explain your answer. What you have to notice is, since this is velocity again, you have to check where t equals 0 and is moving below 0, because that's moving to the left. So the time interval is from 5, 9. 5 is less than x, and x is less than or equal to 9, because the particle is moving to the left, and v of t is less than 0, and that's where it ends, is at 9. C. At t equals 4 seconds, is the acceleration of the particle positive or negative? Explain your answer. What you have to notice, since this is a velocity graph, you have to notice that it's not going to be the same. It's not going to be above 0 or below 0. You have to notice when it is going down, decreasing, or it's going up, increasing. So at t equals 4, the function is going down. And so since it's going down, acceleration is negative because velocity is decreasing. So how you state this: at t equals 4 seconds, the acceleration is negative because the velocity is decreasing. And there you go.
Now here are some practice problems for you to test what you've just learned. Be sure to pause the video so that you have enough time to work out each problem. Pause the video now. Now we'll show you the answer to those problems. Thank you for watching. We hope you enjoyed our video and learned something useful. Goodbye.